Welcome to AI World TV, your go-to destination for everything artificial intelligence. Discover the captivating landscape of AI, where advanced technology finds real-life application. Subscribe to AI World TV for webzine articles, reports, podcasts, videos, live events, and latest trends. Hear from top industry leaders and discover how AI is transforming industries and our daily lives.
Imagine waking up, right, on your 65th birthday.
Okay.
And you just take a quick at-home blood test. Then, maybe an hour later, your health app pings you with a notification saying that, biologically speaking, your cells are only 35 years old.
I mean, that sounds like pure science fiction, honestly.
It totally does. But welcome to the deep dive. Today is Saturday, March 14, 2026, and we're skipping the sci-fi entirely today to look at what's actually happening in real laboratories right now.
Yeah, the real world is catching up fast.
Exactly. We are pulling from a brand new, incredibly provocative feature article that just published today. It's in the AI World Journal, written by Sydney Armani.
And the title is AI and Longevity, the Intelligence Revolution in Human Health.
Right. And our mission today is to figure out how artificial intelligence is fundamentally changing what it means to grow old. Because the core premise of this article, and this really shatters everything we've been taught, is that scientists are no longer viewing aging as this inevitable, unstoppable decline.
Yeah, that's the biggest shift. They are actively framing aging as a treatable biological condition.
A treatable condition, like an infection or a broken bone.
Exactly. I mean, it really requires you to completely rewire how you think about medicine because, we are so used to just treating the symptoms of aging.
Like aching joints or cognitive fog.
Yeah, right. Cardiovascular issues, all of that. But Armani's article highlights this massive convergence of AI, biotechnology, and computational biology. And it's happening right now. They are aiming to target the actual root mechanism of aging itself.
Okay, let's unpack this. Because if we are going to talk about treating aging like a condition, we have to kind of move past the philosophy.
I need to look at the data.
Exactly, the literal data required to pull that off. Because how do you even begin to measure something as vast and, well, abstract as aging in a tangible way?
Well, historically, you couldn't. I mean, at least not efficiently. Understanding the aging process used to mean decades of clinical observation.
Just sitting around watching people get older.
Pretty much. Researchers had to watch a population age over a whole lifetime. They'd try to track genetics, cumulative cellular damage, environmental exposure.
Stress, all that.
Yeah, metabolic changes. It is just an overwhelmingly vast biological puzzle. And the human brain, frankly, just isn't built to find correlations across millions of separate, constantly shifting variables.
We just don't have the processing power for it.
No, we don't. But machine learning models, they're built specifically for that kind of high-dimensional data analysis.
So instead of a doctor, like looking at a patient's chart and noticing, a few elevated biomarkers over a 5-year period, what is the AI actually looking at?
It's looking at multi-omics data.
Multi-omics.
Yeah, so we're talking about massive data sets containing a patient's full genomic sequence, their proteome.
Which is what, exactly?
The proteome is the entire structure of all the proteins in your body.
Oh, wow. Yeah.
Plus clinical records, plus continuous lifestyle data. The AI is analyzing billions of these biological variables all at the exact same time.
That is wild.
It is. And it isn't just looking for, a single gene that, quote unquote, causes aging. It's looking for the network, the hidden network of molecular signals that trigger your cells to degrade.
And Armani's article notes that this is specifically changing the game for neurodegenerative disorders, right? Things like Alzheimer's and Parkinson's.
Absolutely.
But how? Is it just spotting the disease a few months earlier than a human doctor could?
Oh, far more than a few months. Think about Alzheimer's for a second. By the time a patient actually experiences memory loss,
when you can visibly see the symptom.
right, by that point, the physical degradation in the brain has likely been progressing for a decade or more.
A whole decade? Wow.
Yeah. So AI-powered diagnostics are now being trained to detect the biological whispers of these conditions long before any physical or cognitive symptoms ever manifest.
Whispers. I like that.
It's finding incredibly subtle patterns. So maybe there's a slight shift in how a specific protein folds, and that's combined with a microscopic change in your metabolic output.
And the AI sees those tiny things together and says, hey, this is a flag.
Exactly. It flags the disease at its absolute inception.
Reading through this section of the source material, I couldn't help but think of it like viewing the human body as an incredibly complex piece of legacy software.
That's a great way to put it.
Right. Like for centuries, doctors have basically been IT support. They're just watching the computer glitch and crash as it gets older, and they can only try to, I don't know, cool down the processor or reboot the system.
Skate the symptoms, yeah.
But now it's like AI is finally letting us scan billions of lines of source code to find the exact missing semicolon that caused the crash in the first place.
What's fascinating here is how the AI actually does that. It maps multidimensional relationships that human researchers just simply couldn't visualize on their own.
Because it's too big.
Exactly. A human researcher might notice a correlation between maybe 3 or 4 variables. An AI can find a pattern woven through thousands of genetic markers, environmental exposures, and lifestyle factors.
All interacting together.
Yeah, all interacting to cause one specific cellular misfire. It really is reading that legacy code and highlighting the exact interconnected sequence where the biological error occurs.
Which brings us to a massive logical hurdle.
Okay.
Because, okay, let's say the AI can spot the exact missing semicolon in our genetic code that causes Parkinson's or cellular aging.
Yeah, sure.
Spotting a bug doesn't fix it.
No, it doesn't.
How do we actually write the software patch to fix that broken biology without, crashing the rest of the human system?
Yeah.
And that seamlessly transitions us into drug discovery, which is notoriously just a brutal, decades-long process.
It really is high friction. The traditional model of drug discovery, you identify a target, you physically mix compounds in a wet lab, you test them on cell cultures.
Then mice, then humans.
Yeah, and you essentially pray that one of them works without toxic side effects. It usually takes 10 to 15 years.
And billions of dollars.
Billions, with the massive failure rate.
Yeah.
But AI platforms are completely upending that timeline. They are moving the laboratory into a virtual space.
Armani's article gives some pretty wild examples of this.
It does.
You have companies like In Silico Medicine. They're using deep learning to identify the specific biological pathways linked to aging.
Right.
And then you have DeepMind's AlphaFold.
Yeah.
Now, for the listener who might just know AlphaFold as like a tech buzzword, how is it actually changing this process?
Well, to build a drug, you have to understand proteins. Because proteins basically act as the locks and keys of the human body.
Okay, locks and keys.
Right. And for 50 years, biologists struggled with something called the protein folding problem.
Which is trying to figure out their shape.
Yes, trying to predict the complex 3D shape a protein will twist into based on its amino acid sequence.
Sounds complicated.
Incredibly.
Yeah.
But AlphaFold used AI to essentially solve that problem. It can predict the 3D structures of hundreds of millions of proteins with astonishing accuracy.
So it maps the locks.
Exactly. Once you know the exact 3D shape of a disease's lock, you can start designing the precise key to fit it.
And that leads right into the company that really stopped me in my tracks while I was reading this piece.
Chai Discovery.
Yes, Chai Discovery. So they are backed by OpenAI, and the article states they use a generative AI platform to design therapeutics. But wait, let me push back on this for a second. Let me challenge this.
Go ahead.
Because we hear generative AI, and we immediately think of like ChatGPT writing emails or making funny images.
Right.
Are they really engineering medicine? Or are they just using a massive supercomputer to randomly guess chemical combinations until one happens to fit that AlphaFold protein lock? Like throwing computing power at a wall to see what sticks.
It is entirely the former. This is a fundamental shift from guessing to engineering.
Really?
Yeah. Think about how a large language model works. It predicts the next word in a sentence based on the context of the billions of words it learned during its training.
Okay.
Chai Discovery's AI does something very similar, but instead of words, it's predicting the exact sequence of amino acids required to fold into a specific 3D shape.
Oh, wow. So it's generating biology from scratch.
It is.
So it's essentially taking the lock that AlphaFold discovered and custom manufacturing a brand new key that has literally never existed in nature,
Yes.
specifically to turn off a disease.
That is the paradigm shift. The article refers to this as treating biology as an information system.
An information system.
We are moving away from experimental trial and error chemistry and moving into computational engineering.
That's incredible.
When you can literally type the parameters of a disease into a generative model and have it output the molecular blueprint for an antibody in a matter of weeks.
Instead of a decade.
Exactly. Diseases and aging pathways that we previously considered entirely undruggable suddenly become treatable.
Okay, so we have these massive macro-level pharmaceutical breakthroughs happening in supercomputers. But let's bring this down to the ground.
Okay, let's do it.
Let's talk about the everyday person, you and me, the listener. Because the deep dive shifts here from these huge biotech labs to personal daily health data. The phrase Armani uses is personalized longevity medicine.
Right, because generating a brilliant drug doesn't really help if it's applied at the wrong time or to the wrong person.
Right.
This is where macro science meets your daily life. We are seeing an absolute explosion in digital health technologies.
Like where?
You are listening to the AI World Podcast, your trusted source for the latest innovations, insights, and trends in artificial intelligence, blockchain, fintech, and decentralized technologies. Each episode features expert interviews, engaging discussions, and in-depth analysis of how AI transforms industries worldwide. Stay ahead of the curve with the latest articles and exclusive reports from the AI World Journal, covering everything from emerging technologies to industry breakthroughs. For more news, global events, and access to AI World Society circle gatherings, visit us at aiworld.tv. Don't forget to subscribe to stay informed, stay connected, and be part of the AI revolution with AI World Lounge. Thank you for listening.
Wearables capturing continuous physiological data, medical imaging is getting sharper, genetic testing is becoming widely accessible to everyone. All of this is producing massive volumes of personal data every single second.
And here's the critical distinction from the text that listeners really need to grasp.
The age difference.
Yes, the difference between your chronological age and your biological age.
Huge difference.
Because chronological age is obvious, right? It's how many birthdays you've had. But your biological age isn't just a metaphor. It is a measurable metric of your cellular degradation.
Exactly. How quickly your body is aging at a cellular level.
And the article notes that companies like Google and Calico Life Sciences are investing heavily to map the biomarkers that determine this.
Yeah.
We're talking about things like epigenetic clocks and DNA methylation, right?
Yes, exactly. So epigenetics is essentially the control panel that turns your genes on and off.
Okay.
Over time, due to stress, your diet, environment, and just, living your life.
Right.
Chemical tags like DNA methylation attach to your DNA, and they alter how your cells function. That is biological aging.
Ah, okay.
By analyzing those epigenetic markers, an AI can tell you that, hey, while your driver's license says you are 45, your cardiovascular system is operating like a 55-year-old's.
Just imagine the behavioral shift that causes.
Yeah.
Like, imagine looking down at your smartwatch, and alongside your step count and your heart rate, you see your real-time biological age.
It would be incredibly motivating.
Or terrifying. You could literally watch it tick upward after a week of terrible sleep and high stress.
Yeah.
And then you see it drop after a month of adopting a new nutritional intervention.
Or taking a targeted therapeutic. If we connect this to the bigger picture, the future of healthcare relies exactly on that kind of continuous feedback loop.
So it's not just checking in once a year.
Right. The goal of these personalized AI health systems isn't just to give you a terrifying dashboard of your cellular decline.
Good, because that sounds stressful.
Yeah, that wouldn't help. The goal is to continuously monitor your physiological data and deploy agentic AI to recommend highly targeted real-time interventions.
Like what? What would it recommend?
It might suggest a specific fasting window to trigger cellular cleanup, or it might flag that you need an adjustment to a longevity medication. It's actively optimizing your biological age week by week.
But, monitoring the damage is one thing. What if I want to actively rewind the clock?
Now we're talking about regeneration.
Right, because the conversation naturally progresses from just slowing down the aging process to actively fixing it.
And that brings us to regenerative medicine, which focuses on repairing damaged tissues and restoring biological function that has been lost.
And AI is stepping on the gas pedal here too.
Oh, massively.
The text outlines how AI models are analyzing cellular data to predict exactly how stem cells differentiate and how damaged tissue can be regenerated.
Yes.
But the wildest part to me was its application with CRISPR gene editing technology.
Oh, yeah, the simulations.
Right. The article mentions AI simulating genetic modifications. How does an AI simulate gene editing? Are we talking about like a digital twin of a cell?
In a sense, yeah, because CRISPR is an incredibly powerful tool for editing DNA, but in the real world, it can be risky.
Because you could mess up the code.
Exactly. If you cut the DNA in the wrong place, you cause off-target effects, and that can trigger entirely new diseases, including cancer.
Yikes. So how does AI help?
What the AI does is predictive modeling. It maps out the entire genetic sequence and simulates the CRISPR edit virtually.
Before touching a real human.
Exactly. It calculates millions of potential outcomes to predict if there will be any off-target effects before a single physical cell is ever touched.
So it takes the trial and error completely out of the equation.
It drastically reduces the risk. And according to the article, this combination of AI-driven targeting and precise gene editing could eventually enable therapies capable of repairing DNA damage.
Effectively reversing certain aspects of aging at the molecular level.
Yes.
Here's where it gets really interesting. Because when you start talking about reversing molecular aging, people immediately imagine, living to be 150 years old.
Right, the immortality idea.
But the source material highlights a crucial shift in terminology. The medical goal here is no longer focused on lifespan. It is fiercely focused on health span.
Which is a vital distinction.
Can you break that down?
Sure. Lifespan is simply the total number of years you are breathing. Health span is the number of years you are living in a state of good health, free from chronic disease and physical decline.
Because nobody wants medical science to just keep them alive for an extra 20 years if those years are spent bedridden.
Exactly, or in severe cognitive decline.
To put an analogy to it, I was thinking it's the difference between keeping a classic car parked under a tarp in a garage just to stop it from rusting into dust.
Just keeping it untouched.
Right. Versus using a diagnostic AI to scan the engine on a molecular level, predicting exactly which fan belt will snap a decade from now and swapping it out today so you can confidently drive the car cross-country.
I love that.
We want to drive the car, not just keep it on life support in the garage.
That's the perfect way to look at it. Health span is about performance. The preventive AI diagnostics we discussed earlier, spotting cardiovascular risk or neurodegeneration years before symptoms emerge, that's how you extend health span.
You catch it early.
You identify the molecular deviation early, the generative AI designs a specific intervention, and the physician implements it to keep the system running optimally.
But of course, driving that car cross-country with a team of AI mechanics scanning your engine every second sounds incredibly expensive.
It certainly isn't going to be cheap.
And Armani's article does not shy away from the macro-level reality of this. We have to look at the longevity economy.
The influx of capital here is staggering.
It is. You have major venture capital firms, legacy pharmaceutical companies, massive tech conglomerates, all pouring billions into these startups.
It's a gold rush.
The article specifically points to initiatives like the AI World Fund.
Yeah.
They are aggressively funding agentic AI systems for clinicians.
Right, these autonomous AI assistants.
Yeah. Basically, assistants that can parse thousands of medical journals, cross-reference a patient's multi-omics data, and recommend personalized longevity protocols to a doctor in seconds.
The financial engine driving this is massive.
It's unbelievable.
And with that kind of rapid scaling comes a profound set of societal challenges that the article lays out very clearly.
Which is important to discuss.
Yes. If these computational breakthroughs succeed in extending the human health span by decades, we are looking at a fundamental disruption of the global infrastructure.
Because suddenly, the calculus for healthcare systems, housing, and the economy completely changes.
Exactly. The initial wave of these personalized generative therapeutics will likely be highly complex and expensive. So the societal risk is that extending human health span becomes a luxury available only to a privileged demographic.
Exacerbating economic inequality on a biological level.
Right. And as an impartial point here, policymakers and healthcare networks are going to have to figure out how to scale these AI discoveries so they are accessible across diverse populations. We aren't taking a stance on how they should do it, but the challenge is real.
It's an intense conversation that society is going to have to navigate.
Yeah.
Because if we engineer the cure for biological decline, how do we distribute it?
This raises an important question regarding the infrastructure required just to make it work, specifically data governance.
Oh, privacy.
Yes, think about everything we've covered today. Training these generative models requires sequencing millions of human genomes.
Right.
Optimizing your daily health requires a smartwatch tracking your physiological biomarkers 24/7. Building a personalized longevity system requires the continuous ingestion of your most intimate, sensitive health data.
Basically everything about your body.
Yes. Ensuring ironclad privacy protections and ethical data use isn't just a regulatory hurdle. It's the foundational requirement for this entire revolution to even function.
So what does this all mean? If we step back and pull all these threads together.
The big picture.
Yeah. The core message from Armani's piece in the AI World Journal is that artificial intelligence is taking longevity from a philosophical human aspiration and turning it into an applied science.
It's happening now.
We are no longer just observing the late-stage symptoms of aging. We are using machine learning to read the multi-omics source code.
Right.
We are using generative AI to computationally engineer new proteins and drugs from scratch, eliminating decades of trial and error.
Goodbye to the guesswork.
And we are moving away from the archaic goal of simply extending lifespan, focusing instead on maximizing our health span.
And if you are listening to this, the most important takeaway is that this revolution is ultimately about your quality of life. The convergence of computational biology and AI isn't about warehousing you for an extra 30 years. It's about giving you healthier, more vibrant, and more productive years.
Giving you your life back.
It's about ensuring that the time you have on this planet is lived at your absolute maximum biological potential.
It is a stunning horizon to look toward, honestly. But it leaves us with some truly dizzying implications.
It really does.
I won't leave you with a final thought to mull over today, something that builds on this entire paradigm shift.
Let's hear it.
If AI eventually allows us to cap our biological age, let's say we use these generative therapeutics to halt your cellular aging at 40, and it extends your peak health span by 3 or 4 decades.
Okay.
How will that completely shatter our societal timelines?
Oh, wow.
Right. Because if you know your body won't physically or cognitively decline at 65, how does that change the way you pace your career?
You wouldn't need to rush.
Exactly. How does it change the structure of your relationships, your marriages, or your entire concept of retirement?
That changes everything.
If the legacy software of the human body is patched so it never crashes, how do you rewrite the program of a human life?
That's a massive question.
It is. We want to thank you so much for joining us on this deep dive. Keep asking questions, keep challenging the data, and as always, keep learning.
The future of artificial intelligence is unfolding, and it's happening at AI World Week, the flagship global event for innovation, collaboration, and transformation. This flagship global AI event is designed to connect visionary leaders, trailblazing entrepreneurs, and influential thinkers to explore the endless possibilities of AI. Experience groundbreaking technology that redefines industries and inspires progress. Join thought-provoking discussions on ethical AI, digital equity, and the transformative role of technology in our world. Build meaningful connections that catalyze innovation and drive impact. AI World Week is powered by AI World Society, a global movement dedicated to advancing AI responsibly and ensuring it serves humanity. Together, we're shaping a smarter, more inclusive, and equitable future. Continue your journey beyond the event with the AI World Journal, offering expert insights, in-depth analysis, and the latest trends shaping the AI landscape. This is your opportunity to lead, to innovate, and to transform the world with AI. AI World Week. We invite you to join us and embrace the AI revolution.